Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about dilutions. So a dilution is a weakened solution, and there are many applications for dilutions in the lab, in the medical field. And a dilution is a ratio. So a dilution will not have units. For example, when you see 1 to 10 as a dilution, it's a ratio of the volume of the solute to the volume of the solution. So in other words, it's 1 part of your substance or your concentrate or solute in or compared to 10 parts of the solution. The solution is the total volume, which will include both the substance or the solute and whatever you're diluting it with, whether it's saline or distilled water or whatever. Whatever you dilute it with, that's called the solvent. So the solution is equal to the amount of the solute plus the solvent or diluent. So it's the total. Let's take a look at an example. If you were to take 2 milliliters of solute and dilute it with 20 milliliters of saline, the question asks what is the dilution factor. So the dilution will equal the amount of solute, which is 2 milliliters, and the denominator will be the amount of solution. So we're going to have 2 milliliters of solute and 10 milliliters of our solvent. The saline is our diluent, or also called a solvent. So we're going to have 2 milliliters plus 20 milliliters. So it's 2 milliliters. When we combine those things, we're going to have a total of 22 milliliters. When we work with ratios, we can drop our units as long as those units are the same, which they are. So it's a 2 to 22 dilution. And the correct way to express dilution is 1 to something. Different ways that you can find that. The simplest way is to take the denominator and divide by the numerator. So 22 divided by 2 is 11, so that will be a 1 to 11. It could be written as a fraction, or it could be written as a ratio. Or you could use proportion if you wanted to change 2 to 22 to a ratio with 1 to something. You could do that as well. So cross multiply 2 times x is 2x equals 22 times 1 is 22. Divide both sides by 2 and we get 11. So it will be a 1 to 11 dilution. The key is don't forget to add your solute with your solvent to get your total solution. Now let's take a look at some examples where we might have to calculate the amount of solute or solution to get a certain dilution. So when you're doing questions where you're asked to find the amount of the solute or the amount of the solution, I find direct proportion works best. So this question says make 150 milliliters of a 1 to 8 dilution. So 1 to 8 is our ratio. That means for every 1 part of our solute, we need 8 parts of our solution. So we're going to start with that. It needs to be in that ratio. And that has to equal the solute over the solution. So then we determine what it is we know. We want to make 150 milliliters of a 1 to 8 dilution, let's say serum with saline. So that means we're going to end up with 150 milliliters of solution. So this will be 150 milliliters. So we want to know how much serum or solute we're going to need to make that solution. So that's going to be our unknown. We can drop the units. We know that they're both going to be in the same unit of milliliters. So 1 to 8 will equal x over 150. And to solve this, we're going to cross multiply. 8 times x is 8x will equal 1 times 150. And then we're going to divide this side by 8, this side by 8, to get 18.75 milliliters of solute. So this amount of solute in 150 milliliters of solution will give us a dilution factor of 1 to 8. Let's now do an example where we don't know the amount of solution, but we know the amount of solute. So the question says, how much of a 1 to 5 dilution can be made with 4 milliliters of solute? So again, our dilution, our ratio is 1 to 5, and that has to be equal to solute over solution. So our solute is 4 milliliters, and we're finding how much solution. It will be in the same volume unit, milliliters. So we can drop the units and just write it 1 to 5 equals 4 over x. We cross multiply. 1 times x is x. 5 times 4 is 20. This solution has to be in the same volume unit. So we can make 20 milliliters of solution with 4 milliliters of solute. Now, if you have a substance that has a certain concentration and you dilute it, let's take a look at how we can find the new concentration after it's been diluted. So when you take a solution that could be measured in all sorts of different concentration units, and you dilute that solution, and you want to know what the final concentration is, you could use this formula. Your original concentration times whatever the dilution factor is will equal the final concentration. There are a number of different ways that concentrations of solutions can be expressed. Understand that whatever concentration unit is used, when you dilute it, your final concentration has to be in that very same unit. So in our first example, it says a 2% solution is diluted 1 to 5. What's the final concentration? If the original concentration is given as a percent, then I want my final concentration to also be a percent. So I'm going to just plug into this formula. Original concentration is 2%. Times the dilution factor of 1 to 5, I can write that as a fraction, will equal my final concentration. So I'm going to take 2 and multiply by 1/5, so 2 over 5, which can be calculated to be 0.4. It's still percent. So my final concentration will be 0.4% if the original was 2% and it was diluted 1 to 5. In this next example, we have a solution with a concentration of 7.5 milligrams per deciliter. And it's diluted 1 to 8. So now what we want to do is calculate the concentration of our diluted solution. So we're going to start with our original concentration in whatever unit it's given. So 7.5 milligrams per deciliter. We're going to multiply that by the dilution factor. And I'm going to change it to a fraction so that I can do the multiplication. And that's going to be my new or my final concentration. I'm going to leave this unit as is. I'm going to take 7.5 multiplied by 1/8, which will be 7.5 divided by 8, which is 0.9375 milligrams per deciliter. So the new diluted solution will have this as a concentration. Now you might run into situations where you'll know the concentration of a solution after it's been diluted. So let's take a look at how we find the original concentration. So if we had a solution and we diluted it 1 to 4, and then we were able to measure the final concentration of 2%, we might want to find what was the original concentration before we diluted it. So we're going to use the same formula. So we don't know what the original is. So the original times our dilution factor of 1 to 4 will equal our final concentration, which is 2%. So in order to isolate or solve for original, I'm going to divide by 1/4. And remember that when you divide by 1/4, the rule with fractions, it's the same as multiplying by the reciprocal, so it's the same as multiplying by 4 over 1. So what we're going to do is multiply this side by 4, so it will cancel. And whatever you do to this side of the equation, you must do the same thing to the other side. So the original times 1/4 and then times 4 will be equal to 2% times 4. So here this cancels, so we're just left with the original concentration, and it will equal 2% times 4, which is 8%. So the original concentration of that solution before we diluted it was 8%, and when we diluted it 1 to 4, it became 2%. One other question you might be asked involving this equation is, what is the dilution factor? So for example, if you were told the original concentration of a solution is 5 milligrams per deciliter, and the final concentration, so after the dilution, is 2.5 milligrams per deciliter. Notice these have to be in the very same units in order to compare them. We could then find the dilution factor. So plug it into our formula. The original is 5 milligrams per deciliter times our dilution factor will equal the final, which is 2.5 milligrams per deciliter. So to isolate this, we're going to divide both sides by this concentration unit. Now, because they're both in the same unit, I'm just going to drop them to make it a little bit easier. I'm going to say 5 times the dilution, which I'll call x, will equal 2.5. So x will equal 2.5 divided by 5. We divide both sides of our equation by 5. So our dilution factor is 2.5 to 5. We always want to express dilution as 1 to something. Either we can divide 5 by 2.5 and write it as 1 to 2, or we can set it up. 2.5 to 5 will equal 1 to what? We cross multiply. 2.5 times x will equal 5. 5 divided by 2.5 is 2. So therefore our dilution factor is 1 to 2. So the shortcut is just dividing the denominator by the numerator to get the new denominator when your numerator is 1, or you can do it as a proportion. You may need to perform calculations for a series dilution or a serial dilution, and I'm going to cover that in the next video. Also, when we're working with dilutions, we're changing concentrations. So you're going to see this formula, C1V1 will equal C2V2. This C represents concentration, V represents volume. And I'm going to cover changing concentrations with this formula. But before I do that, I want to cover some of the concentration units that you're going to be seeing. So next video will be serial dilutions, then some different concentration units, then we'll get to changing concentrations.